Hello everyone, welcome back to the class of physics by CDR, and in this lecture I will discuss about Thevenin's theorem. Okay, what is Thevenin's theorem? Actually, this theorem is used to simplify a two-terminal linear network, and we can easily calculate the value of current in any component of the circuit. According to this theorem, a circuit containing a number of energy sources and resistances can be replaced by an equivalent circuit consisting of a single voltage source Vt in series with resistance Rt, and this is the load resistance. This is the load resistance through which I want to calculate the value of the current. So, if we apply the Thevenin's theorem at the point A and B in order to calculate the current through RL, this will be the equivalent circuit. So, this is the Thevenin's voltage and this is the Thevenin's resistance. What is Thevenin's voltage? Actually, Thevenin's voltage is the open circuit voltage between the terminals A and B. Let us see the circuit diagram. This is the circuit diagram, and from which we can calculate the Thevenin's voltage. To calculate the Thevenin's voltage, we have to remove the RL. So, this is the circuit for the calculation of the Vt. Let us see. In the second loop, the loop is incomplete. So, no current flowing through the R2. So, the voltage drop across R3 will be the voltage across AB because no current passing through R2. Okay. So, what will be the current in the loop? If you consider the current in the loop is I, so the Vt can be written as I into R3. What will be the value of I? Let us see. In the loop, voltage source is V, and R1 and R3 connect in series. Okay. If we move from positive terminal of the battery to the negative terminal, we connect in the single path R1 and R3. So, R1 and R3 connect in a series in the circuit. So, the total resistance in the loop is R1 plus R3 and the supply voltage is V. So, the current in the loop is Vi by R1 plus R3. Okay. So, Thevenin's voltage will be, this is I, so V R3 by R1 plus R3. Okay. Now, I will discuss Thevenin's resistance. What is this? Actually, Thevenin's resistance is the resistance between the terminals A and B when all the energy sources are replaced by their internal resistance. So, the equivalent circuit for the calculation of the RT is, this is the circuit for the calculation of A and B has R1, R2 and R3. The voltage source is ideal voltage source. Ideal voltage source means the internal resistance is 0. So, this is replaced by short circuit. So, this is the circuit for the calculation of the Thevenin's resistance RT. Okay. And this circuit can be written as, if we can connect R1 just like that. Okay. So, R1 and R3 remain in parallel. Okay. And R2 in series. So, the Thevenin's resistance RT equal to R2 plus R1 parallel R3, or R2 plus R1 R3 by R1 plus R3. So, this is the Thevenin's resistance, and this is the Thevenin's voltage. Okay. And so, the Thevenin's voltage V is equal to R3 into V by R1 plus R3, and this is the Thevenin's resistance. So, the current in the loop IL is equal to Vt by RT plus RL. Okay, so this is the current. Let me show you one example. Let us consider a circuit where supply voltage V is equal to 2 volt, R1 is equal to 1 ohm, R3 equal to 5 ohm, this is equal to 5 ohm, and R2 is equal to 2 ohm, and RL is equal to 10 ohm. By applying Thevenin's theorem, we have to calculate the value of the current through RL. Okay. So the Thevenin's equivalent circuit of the circuit is this is the Thevenin's equivalent circuit. This is, I don't know the value of Thevenin's resistance and Vt. I will calculate the value of Vt and Rt. What will be the value of Vt? For the calculation of the Vt, let's see the circuit diagram. This is the circuit diagram. This is 1 ohm, 5 ohm. This is the circuit diagram for the calculation of the Vt. Okay. So Vt will be, the current in the loop is 2 by 1 plus 5. This is the current, and the voltage across 5 ohm will be Vt. And since the current through 5 ohm is, this is the current, voltage by total resistance. Okay, this is the current into 5 ohm. So 10 by 6 volt or 5 by 3 volt is the Thevenin's voltage. Okay. Now I will calculate Thevenin's resistance. So for the calculation of the Thevenin's resistance, we have to replace the voltage source by their internal resistance, but this is the ideal voltage source, so will be short. Here 2 ohm. So R2 equal to 2 plus 2 remaining series with parallel combination of 1 and 5. So 1 into 5 by 6, and this is equal to 12 plus 5 by 6. This is equal to 17 by 6 ohm. Okay. So this is the Thevenin's resistance, and this is Thevenin's voltage, and we already know RL is equal to 10 ohm. So the IL current through the 10 ohm IL equal to total voltage in the circuit is Vt, and the total resistance is 17 plus 6 plus 10. Okay. Sorry, Vt equal to 5 by 3. So this is equal to 5 by 3 plus 77 by 6, and this is equal to 5 by 3 into 6 by 77. So this is equal to 10 by 77 ampere. Okay. So this is the current through RL. Okay, this is correct. Now, in the same circuit, I will calculate. In the same circuit, I will calculate the 2 volt current through 5 ohm. Here I will calculate the current through 5 ohm. So for the calculation of the current through R3, we have to apply Thevenin's theorem at that point A and B. Okay. So the Thevenin's equivalent circuit will be the same. This is the Thevenin's equivalent circuit A and B. Here this will be the 5 ohm. I don't know the value of RT and VT. So according to the circuit, what will be the value of the VT? Let's draw the circuit. I have to calculate this is 1 ohm, this is 2 ohm, and this is 10 ohm. Okay, and this is VT, this is 2 volt. What will be the value of the AB? This circuit can be replaced by this is 1. Let's see the circuit diagram. Here 2 and 10 remain in the series. Okay, 2 and 10 remain in the series, and so the circuit, this is A point and this is B point. So this is the equivalent circuit. This is 2 ohm and this is 10 ohm. So the voltage across 2 ohm and 10 ohm, that means 12 ohm. So the resultant value is 12 ohm. So the voltage across the 12 ohm is the Thevenin's voltage VT, and this is 2 volt and this is 1 ohm. Okay, so what will be the VT? So VT is equal to the voltage drop across 12 ohm. So first we have to calculate the current through this path. What will be the current through this path? Let's see the figure, circuit diagram. Here the total resistance in the circuit is 12 plus 1 is 13, and the voltage, supply voltage is 2. So the total current in the circuit is voltage by total resistance. So 12 plus 1 into voltage drop across 12 ohm. So into 12. So 24 by 13. This is the Thevenin's voltage. Okay, clear? Now we have to calculate Thevenin's resistance, and for Thevenin's resistance the circuit can be replaced by this way. This is A terminal, this is A terminal and this is B terminal. Okay, 2 ohm, 10 ohm. Here 2 and 10 connect in series. So and the total value is 12 ohm, and this is 1 ohm. This is 1 ohm. So the equivalent resistance between the A and B terminals is the parallel combination of the 12 and 1, and this is the Thevenin's resistance. So RT equal to 1 into 12 by 12 plus 1, this is equal to 12 by 13. This is the Thevenin's resistance and this is the Thevenin's voltage. Okay, and here the load resistance is 5 ohm. So the current through the 5 ohm resistance is IL is equal to Thevenin's voltage VT by Thevenin's resistance RT plus RL. Here VT equal to 24 by 13, RT equal to 12 by 13 plus RL equal to 5. Okay. (24 by 13). 13 into 5 is equal to 65. 65 or 12 equal to 77 by 13. So this is equal to 24 by 77. Okay. So this is the current flowing through the 5 ohm. Okay. Thank you. Next class I will discuss the different application, very very important application of the Thevenin's theorem, different application, and also I will calculate the value of Thevenin's resistance and Thevenin's voltage experimentally. Okay, thank you.